You've seen the mBot2 follow a black line on a white background. But what about making it follow a white line on a black background? Let's dive in to see how we can help the mBot2 master this challenge. Welcome back to Learn as You Explore, your go-to place for mBot2 tutorials. If you are new here, I'm a robotics software engineer who loves helping students learn robotics and supporting teachers who teach it. In today's project, I'll walk you through how to make your robot follow a white line on a black surface, an inverted line follower. This tutorial builds the knowledge and the block program from the original line follower tutorial. If you haven't watched that yet, be sure to go and watch that tutorial first so you can follow along here. I've added links in the description. If you're excited to grab the mBot2 or any accessories, check out the links in the description. I've added Amazon and MakeBlock links. If you use the links, I may earn a commission at no extra cost to you. Thanks for supporting the channel. As far as I've researched, there's no block or Python API to tell the robot, hey, follow the white line instead of the black one. So we're gonna hack the system. Here's what we know from the original line follower tutorial. Again, links are in the description if you want to check that out. Each of the 4 line following sensors, L2, L1, R1, and R2, returns a 1 when it detects a black line and a 0 when it detects white. Since the default assumption is a black line on a white background, our sensors are already calibrated for that. But for an inverted setup, a white line on a black background, we want the opposite behavior. We want to treat white as line detected, which means we want the sensors to report 1 for white and 0 for black. So if we invert the zeros and the ones across each sensor reading in this table, we get the following table instead. The individual sensor bits have been flipped from 0 to 1 and 1 to 0, but then what about the decimal status value? We need to update that as well to reflect the bit flips. Let's take the first row for example. Here we have 1s for each of the sensor readings. So to calculate the decimal status value, we will do 1 times 8 plus 1 times 4 plus 1 times 2 plus 1 times 1, and that equals 15. For the second row, we have 1 times 8 plus 1 times 4 plus 1 times 2 plus 0 times 1, and that equals 14. Doing this across the entire table, we get the following decimal status value update. This shows that when we convert these binary values to decimal again, the numbers are flipped. Originally, we had the numbers going from 0 all the way through 15 as we go from top to bottom. But now we have it going from 15 down to 0 as we go from top to bottom. This is expected since we've inverted all the sensor bits. Mathematically, this means that our white line status is nothing but 15 minus the sensor value. This white line status is what we'll use in our code to replicate the original line following logic, but for a white line on a black background. Now let's take a look at our code from the original black line on white background version. We had 3 main conditions. Sensor value equals 0 means no line detected. Sensor value less than 4 means only right side sensors detected the line. And sensor value mod 4 equals 0, which just means that the sensor value was a multiple of 4, means that only left side sensors detected the line. And finally, in all other cases, both sides detect the line. Now here's the really cool part. Even though the numbers are flipped, the logic still works with the inverted values. Why? Because 0 in the inverted table still means that no line was detected by any of the sensors. Values less than 4, so between 1, 2, and 3, still point to just the right side sensors detecting the line. And values that are a multiple of 4, like 4, 8, and 12, still show that only the left side sensors are detecting the line. And all other values like 5, 6, 7, 9, 10, 11, and 13, 14, 15 have both side sensors detecting the line. The symmetry of math works out beautifully. So let's plan the logic now. All we have to do is to define a new variable called white line status and set it to 15 minus the quad RGB sensor status value. And instead of using the quad RGB sensor value directly in our conditions, we use the white line status instead. We check for white line status equals 0, white line status less than 4, and finally, white line status mod 4 equals 0. If you haven't seen it before, the percent symbol is used to represent the mod operation. And believe it or not, those are all the changes we need to convert a black line follower to a white line follower robot. Let's implement this in our block program now. If you are a teacher and you want to make teaching robotics with the mBot2 much easier in the classroom, check out my Gumroad page for classroom resources. There's even a free pack for you to experience it before deciding to purchase any of the paid premium packs. Thank you for supporting the channel. Open mBlock and open your original line follower program. Let's save this as a new program so we can make changes to invert the logic. I'm going to call it inverted line follower. And say OK. All right, now that we have a duplicate version, let's make changes here. The first thing we want to do is create a variable called white line status. Select make a variable, name your variable, and say OK. Let's grab the set white line status block, and we'll insert it right after the repeat until block, before any of our conditions. And we want to set this white line status to the value 15 minus the quad RGB sensor status. Since subtraction is involved, let's grab a subtraction block from the operators category. The first operand is 15, and the next operand is going to be the quad RGB sensor's status value, which we can get from the quad RGB sensor category, and getting the quad RGB sensor line status from 0 to 15 block. Drag that onto the second operand, and now we can use this to set our white line status. Next, we need to update the conditions for our if blocks. Instead of using the quad RGB sensor value directly, let's get rid of that. We want to have the conditions based on the white line status variable. The first condition is checking for 0. So let's go to operators, grab an equals comparison block, and we want to check for the value 0. And the first operand is going to be white line status, which we can get from the variables block. Grab that and drop it into the if condition. So here we're checking if white line status equal to 0. Now we're done with the changes to the first condition. Let's move on to the next condition, which is quad RGB sensor status less than 4. Instead of the quad RGB sensor status here, let's get rid of that. We will use the white line status from the variables category. And that's it for the update to the second condition. Finally, the third condition also uses the quad RGB sensor status, which we will get rid of, and replace it with the white line status variable. And that's it. We have all the changes that we needed to make to help the robot follow a white line on a black background. Let's save this project. We can now upload this project to our robot. Click Connect, select the COM port, click Connect again, and select Upload Code and wait for the program to be uploaded. Let's go to the robot and see the program in action. If you've made it this far in the video, please consider giving the video a thumbs up by clicking the like button and subscribe to the channel if you haven't already done so. It really helps keep the channel going. For the setup, I just used some black cardstock and white masking tape to make this white line follower sheet. You should be able to find these items at your local arts and crafts supply store. Press button B to start the robot and watch the robot follow the white line just as well as it did with the black line in our original line follower tutorial. Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.